Okay, in this video we'll talk about free form motion. So we need to understand what free form motion is. Okay, so before we continue, basically what we need to understand first concept is when you throw an object up, what happens? What makes it to come back down on ground? Those are the basics which we need to understand under free form motion. Yeah, so now let's begin. Now first of all, we need to understand to say we have been doing the equations of the motion. Okay, so here we are talking about the motion. Okay, we're talking about the motion. So we need to understand that we have x and the y direction. Okay, so what we need to understand is when we were using the equations, those four equations, we were talking about the direction in x direction, or the motion in x direction. Now we were saying acceleration, maybe you calculate the acceleration and everything, you're going to be given, you calculate everything. But now we want to talk about the direction in y, or y direction. How can we calculate the distance or everything in y direction? As we can see, under y direction is the same as if I throw something. If this is my ground, okay, if this is my ground, then I throw something up. I throw maybe a ball up. It's going to reach a certain height, it has to come down. Okay, so that is what we want to look at. Okay, so there we go. Let's start. Okay, the first thing we need to understand here is everyone has, maybe you have tried to throw an object up. You are wondering why this object is coming down. Why doesn't that object just stay in air? Now what happens? Okay, so that is what we want to do. So let's say you have, this is the ground, then you have a ball. I want to throw a ball. You throw it up, it's going to reach a certain height, comes back. What makes that object to start coming down, or what makes it to reach at that maximum height? Okay, there we go. Before I explain what makes that, we need first to understand something. So the principles of free form motion is the first thing is if I have two masses, if I have two objects, let's say this object has got 5 kgs and this object has got 10 kgs. Now I want to throw this object using the same velocity. I want to throw this object using the same velocity. Maybe let me say the initial velocity is 5 meters per second. The initial velocity is 5 meters per second. Now if this is my ground, now what will happen to these two objects? Now if I throw these two objects at the same time with the same velocity, they are going to reach on the ground at the same time. That we should know. Now if these two objects, despite having the different masses, but they are going to reach on the ground at the same time. Now the reason is, let me say this is my object A, this is my object B. Both object A and B, they are moving with the same acceleration due to gravity, which is 9.8 meters per second squared. So this is the reason. These two guys, they are going to reach on the ground at the same time. The reason is they are all moving with the same acceleration due to gravity. Okay, another concept is a free fall does not depend on mass. So it doesn't depend on mass. No, it doesn't depend on mass. That is what we can say. Now, what if we change the material, or we change an object? What do I mean when I say we change the object? This is what I mean. So let's say maybe we change the object. The same velocity, we maintain the same velocity, but let's change B. Let's say we have got a paper. So this is just a paper. So what will happen? You throw them with the same. What will happen? This is our ground. What will happen? You are going to discover to say object A is going to reach on the ground faster than object B. Why? Because of air resistance. This object, for it to reach on the ground, is going to go that way, comes there, it goes there. As a result, it's going to take time for this object to reach on the ground. Okay, but what if I fold that paper? What will happen? Okay, what if I fold that paper? We need to understand. What if I fold that paper? So that is a paper. Now I want to fold it. What will happen? Meaning I'm going to reduce the air resistance. So I'm folding that paper. That is my paper. So what will happen is that if I throw this paper with the same velocity as 5 meters per second, what's going to happen is that they are going to reach on the ground approximately at the same time. So object A, approximately at the same time. Not necessarily the same time, but approximately at the same time. That is what we need to understand. Okay, so if there is no air resistance, these two objects are going to reach on the ground at the same time. Now the question can come. You have an object A having the mass of 100 kgs and object B having the mass of 10 kgs. You throw them at the same time, or you throw them with the same velocity. What will happen to the time? Just know to say they are going to reach on the ground at exactly the same time. That question may come. Okay, so another issue which we need to understand is what causes this object to come down. Okay, that is what we need to understand. So what makes these two objects, or any object, when you throw it, it comes back the ground? What happens? So this is the concept here. Let's say we have the ground and I have my object there. I throw it. It's going to reach at a certain height. It comes back. What happens there? So any object, when it's moving in y direction, in short, in free form motion, the object is just moving freely. Just know that the acceleration which is moving with, it is 9.8 meters per second squared. Some people, they can say it's 9.81 meters per second squared. Basically it is just the same thing. Okay, so we are just making it into significant figures. Okay, so here we'll be using, in this video we'll be using 9.8 meters per second squared. Okay, so what does this mean? The moment when the object starts now going up, this object, the velocity is going to be reducing. Okay, the velocity is going to be reducing. The velocity is going to be reducing by negative 9.8 meters per second in each second. What does this mean? When we say a car is moving with the acceleration of, let's say a car is moving with the acceleration of 2 meters per second squared, the meaning of this is that particular car is moving with the velocity of 2 meters per second in every second. So in every second, the speed is going to be increasing by 2 meters per second. 2 meters per second in each second. So this gravitational force, or the value of g, it is just showing us how the speed or how the velocity is changing. So as we go up there, as we go up, is going to be reducing by negative 9.8 meters per second in every second. Therefore, we are going to have 9.8 meters per second squared. Now, you are going to reach at a certain point where the velocity is going to be 0. Meaning, if something is not moving, the velocity is 0. Or a car started from rest, meaning started from 0. So, the moment when we reach at the stage where the velocity is going to be reduced until it reaches 0, meaning we have reached at the maximum height. Okay? So, what do we say? Let's review. We are saying, if we reach at the velocity where is equal to 0, meaning we have reached at the h max. Meaning the velocity at that particular point is that is the maximum height. So this is what we say. This is what we are saying. So we are saying that let's just review what we have said. We are saying that when we throw an object, if you have the ground, you throw an object up, it goes there, you throw there, it goes, it comes back. Okay, so at that particular point, this point, meaning here, that is this distance, that is our h max, the maximum height. The maximum height. Now, what happens at the maximum height? We are saying that the velocity is what? So, we are saying that the velocity there is supposed to be what? 0 meters per second. The moment when the velocity reaches at 0 meters per second, then the object has to start now coming down. That we should know. But, let me take you back a bit. Now, how can we calculate the time it takes for that object to go at that particular point and everything, the acceleration, or maybe the maximum height, the final velocity, the distance it covered, everything? How can we calculate in free form motion? Now, if you can remember very well, we talked of a number of issues in terms of motions. We said we can calculate the anything under equations or maybe motions using 4 different equations. We said the first equation, we said it is Vf is equal to the V initial plus At. Then the second equation, we said S is equal to V naught times time plus half A T squared. Now 3, we said V final squared is equal to V initial squared plus 2 S. Now, in this case, S is the same as the height, or S is the same as the distance. Okay, so S, you can replace it with the distance, or you can replace it with D or H. Now, sometimes when we are dealing with the motions of or maybe the motions in X direction, you can also say your S. You can also say S is the same as the X. Now, when we're talking about motions in Y direction, okay, when we're talking about motions in Y direction, then S is the same as Y. So all these things, you can replace them, it is the same thing. Okay, so in this video, we are going to be using the distance or displacement or height as our S. Okay, wonderful. Then now, what next? What next are we supposed to talk about? Now, these are the equations we were talking about when we were doing the motions in Y or in X direction. And you can use any of the equations to calculate the distance covered by an object, the distance covered by the car, the final velocity, or let's say the final speed and everything. But now, these equations which I've listed here, we are using them in X direction. We're using them in X direction. That's what we said. Now, we want to talk about something else in Y direction. So in Y direction, we are saying this acceleration is no longer linear acceleration. It's going to be the acceleration due to gravity. So the only thing which is going to change in these equations is where there is A, we are going to replace it with G. The moment when we do that, then these are the equations we are going to be using in a freeform motion. Okay, so let's do that. Let's go and do that. So we can just remove this, also remove this. So now we're talking about the y direction. We are saying, let's review. We are saying where there is a, we replace with a g. Then then there we go. We go there, we change here. We're supposed to change this one, then and that one, also that one. So there we are supposed to replace with the g. Meaning these are the equations in y direction. Okay. So now, how can we use these equations to calculate, or anything which we can use to calculate? Okay. How can we use those equations? Okay. Now, under freeform motion, what we need to understand, guys, is this. We said we can calculate the time, or maybe we said we can calculate that. Maybe we have something like, you have an object, then that object is going up, it comes back. Okay, so we are saying at that particular moment here, at the maximum height, this is our h max. Then we also know that at final, when it reaches at the maximum height, the final velocity is 0. Okay, so I want us to understand something here. If this is my point A, that is my point B, and that is my point C. Now, how can I calculate the time? If I've been given everything, how can I calculate the time from point A to C? Okay, so we can calculate the time from point A to B. First, we start from point A to B by using any of the equations except one equation. This equation cannot work because we don't have time, but you can use equation 1 or equation 2. Okay, but sometimes equation 1 is going to be simple because we are going, in case we don't have the maximum height, we can use the equation 1 to calculate the time it takes from point A to B. Okay, so we are going to do examples there, no problem. Now, what if we want to calculate the time from A to C? How can we do that? The only method which we can do there is we need just to double this. The time it takes from point A to B, it will be the same time it will take. So in short, the time it takes from point A to B, it has to be equal to the same time it will take to point B to C. Therefore, if I want to calculate the time it takes from A to C, I need just to find the time it takes from A to B. Then the answer which I found, then I need to do times 2. So in short, this times 2, that is this. Simple, right? Okay, this is how we can understand the freeform concept. Now, what if we have got some questions? How can we handle them? Okay, now another issue is okay, let's first do this. Do that. Okay. Okay. So now, let's say maybe we have a ball, and this is the ball, and it has the initial velocity of 20 meters per second. Now this ball is going up. Okay, now this ball is going to reach at a certain height. Okay, you throw a ball with an initial velocity of 20 meters per second. Now we need to calculate the time it takes for it to reach at the maximum height. Okay, how can we do that? Okay, so how can we calculate the time it takes for it to reach at the maximum height? We know that we don't have the maximum height in this case. First of all, let's gather our data. We can gather our data. We know that we have the initial as 20. We have the final. We know that when it reaches at the maximum height, the velocity is going to be 0 at that particular moment. We also have the g. Since it's going up, we can take as our g as what? Negative 9.8 meters per second. Sorry, I didn't mention about the g. So now we know that when it's going up, we are reducing the value of this velocity or this acceleration due to gravity. Therefore, when it's going up, we are going to take our g as negative 9.8 meters per second squared. When it's coming down, since we are going toward the gravity, then we are going to be taking positive 9.8 meters per second squared. But this is not always whereby you should be taking this as negative when it's going up, or positive when coming down. There are some situations whereby you cannot use negative when going up, but in most cases we are taking g as negative when it's going up. Okay, please take note on that. Okay, so now let's go back to the question. How can we do that? How can you solve it? So we can solve that question using simple equations. Since we said our v final is equal to v initial plus a t, but now in this case I can't use a because we are talking about the acceleration due to gravity. Okay, so I have my initial, I have my final, I have my g. I can calculate t. Okay, there we go. So we can say we have our 0, then we have our 12 or our 20, sorry. We have our, since it's going, our negative g, which is going to be negative 9.8. I cross, then I have t. So I'm going to shift this guy to the other side. I'm going to have negative 20 is equal to negative 9.8 t. I divide both sides by negative 9.8, both sides by negative 9.8, and I'll be able to get my time as, get my calculator. I have negative 20 divide 9.8. So I'll have my time as 2.0 seconds. Now, this is the time it takes for it to reach at the maximum height. Okay, but the question can come, how long was it in air? Meaning they're asking about how long was it when you throw it until it comes down. The time which we have calculated here to reach at the maximum height, if I just do times 2, that will be the total time it takes for it to reach on the ground, or how long was it in air. So 2 times 2, I'm going to get 4, meaning we had 4 seconds. That was the time it takes for it to be in air. Wonderful, right? Now, how can we calculate the height? Okay, how can we calculate the height? So we can use number of equations to calculate the height. So like we said, we have everything. We can calculate the height. Which formula can we use? Okay, now in this case we are trying to use any 2 equations here, but the best thing is we are trying to avoid the equation where we can plug in time, unless we don't have any equation which can work. Try to avoid using the values which you have calculated yourself. Okay, because what if I use this equation? Okay, let's go back a bit. What if I use this equation? This equation definitely it can work. This equation definitely it can work. But okay, this equation can work, and this is the best equation. What if I use this another one? It's possible I can use my s. Let me remove this. Okay, it's possible I can use s is equal to v naught plus half. Okay, but what if my time, the one which I have said 2.0, and you remember, if you have calculated this, I've just rounded off. this one to 2.0 seconds. But what time was not correct, meaning if I use this equation, the answer which I'm going to get at the maximum height is going to be wrong. So I need to make sure to say I use the equation where I cannot plug in the values which I have calculated myself, unless you don't have that equation. Okay, so there we go. So now both equations can give us the same answer, but what if we made a mistake? That we should do be in your mind. Okay, so we can use this equation to calculate our maximum height. Okay, so how do we do it? Let me just erase this so that we have our data there, and we can also add time, since we have said our time is 2.0. But anyway, we're not going to use it. Therefore we come here, we start now plugging in the values. So I start with the final velocity. We said at the maximum height it's going to be 0. Okay, here we have 20 squared plus 2. Now at the maximum height we are saying it's going up, it's going to be negative, so the value of g is going to be 9.8 s. So like in this case I can press s. Since I'm talking about the h max, I can replace x with h max, no problem, no one is going to penalize you. So therefore I'll come here and replace this, and I'll say h max. Therefore I'm supposed to shift this guy to the other side, but it's going to be negative, so it's going to be negative 20 squared is equal to I have 9.8 h max. Okay, I can get my calcu. I have 20 squared. Here I'm going to get negative 400 is equal to, if I have 2 times 19, or 2 times 9.8, I have 19 twice, so it will be negative 19.6 h max. Divide both sides by negative 19.6, and I'll have my h max as, I'll have 400 divided by 19.6. Our max as 20.4 meters, and this is my answer. Okay, that's how I can calculate the h max. Okay, then sometimes you can be asked this question. Okay, sometimes you can be asked the question, and how can you answer it? Sometimes you can be asked this question. Now what if you have been asked to say what was the velocity just before it's caught? Okay, now we say when an object reaches, when the velocity is 0, that object is not moving. That's what we said. Okay, so now what if we have that, it comes there. Now what if I throw this ball with the an initial velocity of 20 meters per second? It reaches there, the final is going to be 0 meters per second. But the moment before I catch this object here, the velocity has to be the same as the initial velocity, but it's going to change the sign. It's supposed to be negative 20 meters per second. You can use any of the equation, you can come up with that answer. But here is we are coming, since it's coming to rest, the velocity has to come back to 0. Okay, but so if I do 20 minus 20, it's going to be 0, right? Okay, but I can use any equation, I'm going to come up with 0. Okay, but we should, when the velocity is positive, meaning an object is going up. When the velocity is negative, an object is going down. That we should know. Okay, so those are the basic things which we need to understand under free form motion. Thank you for watching this video.